Okay, our next talk is going to be on laser-based engineering services for the repair and maintenance of high-value plant components. And really the teams that have developed and are implementing this technology are doing fantastic work behind the scenes to keep both our electricity on and our plants going, repairing very, very key components to the South African electricity supply and economy. And the value that they add to the South African economy is incalculable, and they don't get a lot of press, and people don't see what quality and what fantastic people are still in the country and what technologies we do have. So the speaker that is going to speak about this is Dr. Lerato Tshabalala, my colleague, who has joined the CSIR in 2016 as a senior engineer, and in 2017 became the technical lead on the Aeroswift flagship project in high-speed, large-volume additive manufacturing. She's currently the research group leader for the Laser-Enabled Manufacturing Group at the CSIR Photonics Center, and she holds a D.Tech in Engineering Metallurgy from the Tshwane University of Technology. Her research interests are in materials processing and in product development, and I'm going to hand over to Dr. Tshabalala to talk about this very important technologies that's currently being developed and implemented.
Thank you, Hanjo. And good afternoon to everyone. Excited to be here talking after most of the speakers and all the technologies that we are actually working on. And I think Darrell's presentation shows how we actually interact and work well with industry. And the drive for this has been going on for quite a while in the CSIR, especially in our team, in the Photonics Center. And today I'm going to present to you what we've been doing over the years and even currently to actually look and to sustain the technology transfer into industries. Okay, so my presentation today, yes, is going to be on the laser-based engineering services, and we've all had a crash course on what the laser is. So in this case, we are now the application of laser technologies. Okay. All right. And in earlier discussions, we've seen what 4IR or Industry 4.0's impact has been and the challenges that we are being currently faced by the general globe. And all of this has created what I try to avoid going to the 4IR terminology, but saying the great shift in technology or in how we do manufacturing and how we function. So in the past, many decades ago, we had a centralized production, and we've moved slowly to a supply chain environment and started stocking up on inventory to just avoid long lead times. And recently now we are more moving towards more customized approach for manufacturing and also for manufacturing and also supply chain of products. Okay. With this great shift, therefore, we've seen there's been a lot of focus in the past, more in quality focus, using lean production systems so that we can actually get production just in time, pull policies, still try to introduce electronic data into the manufacturing systems. However, what we've seen now is that we need to move more towards customized products. What Darrell shared was a more customized product that had to be informed by the end user, and working closely with the end user as a research institute makes this customization really adaptable and really quicker for industry to actually take hold. So yes, this has brought about now more towards smart manufacturing, where we now have to build based on the economies of scope, considering the global manufacturing capabilities. As South Africa, we need to move more agile and have more agile systems in manufacturing. You've seen that we've had the timelines in getting that system into operation, and most of these things are mostly now internet-based. So in terms of our group, our focus, we within the manufacturing cluster, and we incorporate R&D programs, laser-based consultations, process development, and decision support for industries. We push industrialization and implementation of all these technologies, and in most times now we offer manufacturing support through services. The technologies that are accessible to industry at this stage cuts across mature technologies like laser cutting, laser welding, laser hardening, laser engraving, or milling or machining of surfaces. And what has brought about now or grown to new technology has been this laser metal deposition. Laser metal deposition has been used over the past years as a coating mechanism for improving surface properties of metals. And with that, and the know-how around that has also evolved to actually laser additive manufacturing of actual 3D 3D parts in general. And this technology we've all seen, I mean, it's now revolutionizing how we do manufacturing within different sectors. And another technology that is also moving swiftly into industries has been the laser shock peening. Laser shock peening is a technology that is also used to actually do surface modification and also correction of some of the deformations that you get when you're doing machining or producing parts. So these are all the technologies that we have at the disposal of for many industries that we've got in the country, and we continue to qualify and have systems transferred into industries. So we've got two groups, one looking more into the research and development and transferring these technologies into service through a group called Laser Engineering Services. Okay. So we have seen over the past years the many advantages that laser-based engineering has provided to companies. I'll show a few case studies in the next slide. But generally, we've seen cost savings in terms of providing alternatives to components replacement, that instead of actually throwing away most of the material of the parts that are in operation, then we are able to actually refurbish and actually reduce the cost of of the components. And that also provided us opportunities to actually improve the performance of some of the components that we actually refurbish, thus at the same time increasing the lifetime of those parts in operation. In terms of technical advantages that we've seen the laser technology in operation has always been that, the system is automated, so there is exceptional process control in adopting the technology. The laser, how we would control it, we are able to provide to apply low heat inputs, high flexibility in parts or in areas that can be actually refurbished. We have qualified these processes, you'll see in the next slides. We've got faster throughputs because of that automation advantage, and reduction in environmental impacts. We're reducing the impact on environment. If we're not going to actually produce by casting and we're going to have more parts repaired and put back into the system, so those energy and environmental impacts are actually reduced in this way. Yes, we've got low energy. The systems use low energy consumption, and that's, I think, a good one in terms of savings as well. So in terms of what we have done in the past, we've done a lot of work. The development work for our energy sector has started long in around 2013, and this was trying to develop a process for actually repairing or rebuilding of blade tenons on the steam turbine stage 3 root blades. So these are actually really critical to our power generators, and the long lead times was mainly because most of the time, if there is in the steam turbine rotors, you find that you've got about 4 stages, and you've got a shroud that actually holds these turbine blades. And if that shroud or any part of the steam turbine rotors gets damaged, all the turbine blades, there's about 128 of them on the system. If the straps or the shroud that actually holds the system together gets damaged, you get to have to remove almost or all 128 blades and have to replace those blades with new ones, because you would have cut off some of the top pieces. Let me just show something. You'd have to cut off some of the tenons at the top here, and when that is removed, when these are removed from the blade becomes useless. So together with ESCOM research team, we found that there is an opportunity to use 3D printing to actually build up the tenons that actually gets attached to the straps for these blades to actually run in the steam turbine. So a lot of development went in to actually qualify that the rebuild so it's a hybrid where you've got old blades and you rebuild these using the technology. And this was successful. A few procedures were actually developed through this process. We found a way to only remove a short section of the shrouds on the system. We were able to develop a procedure to remove or to do non-destructive testing of the materials that were actually built on. And we were able to do in situ post-weld heat treatment processes on the newly printed parts. And these are difficult to actually do. These are processes that are actually very difficult to implement, especially in a harsh environment. As you would see, the sizes of the steam turbines that we would have to handle. So with all of that, these in situ now strap repairs has been successfully done at the Duva rotors, and replacements have also started in the Majuba and three others from Dover rotor. So this work has been done successfully together with Rotec with Rotec as a service provider to Eskom. But this is really good. It's a good way to actually show and demonstrate how industry and the CSIR can work together and implement and roll out these technologies to better improve the systems that are currently out there. So at this stage, we are at the point of actually piloting more and rebuilding more blades for Eskom. And there's also other projects in other sectors like Sasol, where we do restoration of compressors. This includes welding of general rotors, blades, as well as the tip of the blade that is visible. And as I said, we have seen a significant improvement in the efficiency of the rotors itself, and we have seen energy cost savings. Okay. The other sectors that we've also worked with is the mining sector. We have seen that with replacement or refurbishment of components from the mining sector, there is also real cost savings. A market study was done with the supply chain, and we saw that some of the replacement costs would run between 800 and about $1 million per event of replacement or maintenance, during maintenance. And these included all the component itself, the repair time maybe on the brackets, the logistics and the labor for actual replacements of some of the components, be it for the new ones. So if we implement refurbishment using the laser technology, we are also able to actually save on the lead times. And we have seen a significant application where we were able to have more time saved, more time of parts in operation, and that was really good for the sector. So this has direct impact on now maintenance cost, has direct impact on productions. It has direct impact on the capital investments that are actually being saved, and then obviously also we're pushing cost. Now, the question becomes, how do we push services into industries? For some time, there's been maybe confidence in the processes that we do, but with the work that we have done so far, we've really gained significant confidence in the work that we do. And it's important. We've talked about smart manufacturing and getting more agility into implementing these technologies into industry. So for all of these, we will need still access to data. You've seen how working together with companies like DBS has actually evolved and been able to provide the right solution for the industry. We need access to personnel interviews. We need to access to those skill sets that will actually provide us provide a holistic solution to this. We're moving into a digitized systems. We will have to have access. There will have to be integration of these systems into the greater infrastructure, IT infrastructure of the businesses. Green light on new industries. We need approval for testings. So all this information together, also with feedback on the parts installed. What we've seen today was that feedback from what the interactions between the CSIR and industry would be. And yes, that is where I end my talk. Thank you very much.
Okay, thank you very much, Dr. Lerato Tshabalala. We've got time for a few questions, also for the previous speakers, but let's start with questions for Dr. Tshabalala. Any questions from the audience? There at the back.
I'm sorry, but my question's for the previous speakers, if that's okay.
Okay, maybe while they come up, then just give them a few moments and then they can come up.
Sure.
Yeah, just to make a comment on what Lerato has presented here, you see these pictures, but you don't realize how big these turbines are until you go visit the various facilities. It really takes your breath away. And just the complexity of what these people are doing and what we've developed and how much time and money it saves the country is really, really, really impressive. If you can go visit Man Energy or Eskom Rotec or any of the other providers of these big rotors, then I would urge you to do so. It's really, really impressive. Okay, so I think you can ask your question.
Great, thank you. So when you answered the first question, after your session, you had mentioned how it wasn't a novel system, but there's some new components in how you design the entire thing. My question for that is, how do you handle the IP in a commercialization space like this? Does it sit with De Beers with CSIR? And if it sits with CSIR, how do you manage that?
Question for you.
Was it for me?
It's more a question for Henschel, but yeah, I mean, in terms of this situation, how we handle it typically is it's the same thing like if you would go to a shop to buy something. If you're paying the full cost for it, then it belongs to you. But if you want to lease it from somebody, then there'll be an agreement moving forward based on royalties or a payment plan or such and such. So it really just depends on actually the cost structure behind how that technology moves forward. But in this case, De Beers obviously funded the majority of it. We had also put in a lot of our own funding, but that was to ensure that we had been able to develop the best product moving forward. Then the actual systems moving forward, De Beers will buy them from us like it's basically we're a supplier and they're a purchaser.
All right, does that answer your question? Yeah, so De Beers bought the laser from the CSIR. We developed it together with them, but essentially they bought the laser. So what this what this provides us is now the ability to commercialize this laser by selling it first to them, but also looking at new markets. So ultimately, what the recipe is to assist our local industry to become more competitive and to help them, and then by doing that, eventually to spawn new entities that can produce high technology within the country. Also for export to other markets. Yes.
Great presentations on lasers, and you helped us understand how these things work. So just two questions, and the first question goes to both the presentation. I mean, we are in an environment where we trying to start up new high-tech enterprises. And with both your presentations, and bearing in mind that we also come with these challenges of trying to do transformation and empowerment and all sorts of things, how are you going to lower the barriers to accessing these technologies for young people to start up enterprises in collaboration with the CSIR? I mean, if you look at the DBS situation, we all know diamonds and money go together, so that wasn't a problem there. So, but when I come along, I won't have the kind of money to tap into these technologies. That's the first part of the question. The second part is, with what you, Darrell, and on the DBS side, did you register a patent on this technology? If yes, was it in South Africa or somewhere else?
Okay, well, we'll answer the second one first. There was no need to register a patent. I think the design of these types of systems is fairly standard. Let's put it this way, the approach is standard. The actual deciding on what numbers to use, that comes from our own knowledge. So that sits as complete know-how. But it's not like a huge new advance for us to be able to patent it. Maybe in the application itself, that could be a potential. But that's something we will have to discuss with De Beers moving forward. But it's not likely that that a system like this would be. I mean, I think especially in general with localization as well, it's very difficult to patent those new systems that you would develop. They're new to the country, but I think they already exist. In terms of accessing equipment and opportunities, so at the Photonics Center, we have something called a photonics prototyping facility. And the point of this facility was designed to provide access to individuals or SMMEs to come and develop prototypes and have access to very high-tech equipment as such. But there's a couple of facilities that exist like that within the CSIR. The biomanufacturing one is another one. You saw with the learning factory in the previous session. That's another one. So these opportunities to have access to this equipment exist. There's a variety of funding models that go with it as well. For instance, if you have no money but you've got an amazing idea, then in most cases the CSIR will be more than happy to bring you on board. But then there'll be a revenue sharing process that'll happen. It'll be project specific. But really access to high value equipment and high value processes is what we do at the CSIR. So, and there's definitely means to be able to do that.
Great.
Yeah.
Thank you. Thank you very much. Okay, one last question before we break for lunch.
Thank you very much. Thanks for the presentations. As the CSIR is not a manufacturing outfit, that you're a research and development organization. So now you have this great laser project and you've sold it to De Beers, but now what is the next step? You don't want to see another lithium case in South Africa. So what is the next step to make sure that some local industry develops out of this, rather than it being exported?
Yeah, so I mean, I think within all of us actually, we have a very strong belief of creating spin-outs from the CSR. So leveraging that technology and spinning out. If we don't want to personally do it within our teams, then finding partners who are interested in doing that and then licensing that actual technology to them. But I think Lerato can probably add more from her side as well. But I mean, that's our general vision, is to actually spin these things out and not just leave them as a single development moving forward.
And that also comes from what we saw as the laser engineering services. So that is a platform that we are spinning out to actually translate to more industries, because the technologies are now qualified and they are known, but there's still R&D that still supports that, so that we always remain competitive.
Yeah, so again, as I say, if we don't get these technologies out as products in the field, then they've essentially died in the womb, and there's been enough of that in the past. So I think all of us are really focused on actually in the end creating jobs. That's the ultimate KPI. What jobs are we creating for the country? Okay, if there are no more questions, we will now break for lunch. And I think we'll be back here after lunch.
The next session is like at 2 o'clock.
Yeah, so next session is at 2 o'clock. So there's an hour for everyone to ask more questions during our break. Thank you so much.